All right, everyone. Today's live stream, we have Rumi Allbert. He'll be talking about identifying and manipulating personality in large language models.
Very cool. Welcome, Rumi. Thanks. Do you want to just give a brief introduction and then share your screen and we can do the presentation?
Sure thing, yeah. My name is Rumi. I have a background in data science, a bachelor's in data science, a master's in the humanities, with a focus in philosophy. So most of my interests are sort of the overlapping of technology, philosophy, and humanity-based questions. So that's sort of where this project brought me to. So let me go ahead and share my screen with you guys. Okay. Thumbs up if you can see it okay.
Yeah, we can see it.
Yeah. Okay. Yeah, so the project I've worked on and the research I've been doing lately is identifying and manipulating different personality traits in large language models. It's sort of like a novel technique that I've been working on, so I think it's quite exciting to share with you guys. But before I get into that, I want to share sort of the motivation and sort of what started the base of this project. And that came from this paper published on LessWrong.com. It's titled Refusal in LLMs is Mediated by a Single Direction. So this paper essentially finds a way to jailbreak and bypass the refusal mechanism in LLMs. And this is from the paper. And I think it's quite interesting, which is thinking in terms of features. So as a rough mental model, we can think of a transformer's residual stream as an evolution of features. So at the first layer, the representations are simple. They're very simple. And basically, it starts at the level of token embeddings. But as we pass through the different layers, the intermediate layers, the representations become more and more enriched and more comprehensive. These are higher level features. So then at the very later layers, these enriched representations are actually transformed back into the on-embedding space and converted back to the output of the model, so the output tokens. So if you are familiar with convolutional neural networks, it's sort of what they do is sort of the same idea, which is the model begins by learning very abstract and simple features of the image, in this case, a text. So for example, down here we have the representations of the face. So we have like the contours of the face, we have the edges, and that's at the beginning layers. In the middle layers, we have sort of the representation of circles and maybe the eyes. And at the very last layers, we have, well, the face. So these features put together. And this is actually the case with basically any model of this size, which is we have the rough edges, we have the abstract features. We get more enriched features as we go through the layers. And at the very end, we have sort of the rich combination of these features. So essentially what this paper is saying is we got to think of LLMs as sort of the same process, which is we begin by the simple token embedding, then we get a very complicated interactions with these features, and at the end we actually have the output. So then the hypothesis of the paper and what they actually proved is that we can, sorry, give me a second. So we can actually have a wide combination of harmful prompts, and we can find an intermediate feature which is instrumental in the model's refusal. Basically, in other words, many particular instances of harmful instructions led to the expression of a refusal mechanism or refusal feature in the model. So then this refusal feature is expressed in the residual stream of the model. And that's basically when the model says, hey, I should refuse this request for this prompt. So for example, in this image here, we have the token embeddings at the initial stage. So maybe we ask, how can we build a bomb? So this feature of bomb, the embedding, actually goes through many different interim, like intermediate feature combinations or sort of learning. So these features, they might be, a weapon, it can be dangerous, it can be this or it can be that. And at the very last layers, we have a feature which is sort of the, should I refuse or should I actually approve the output of this this request or this prompt? In this case, if we ask something about LSD or bombs or how to make a phishing email, we go through all the features, through all the layers, and at the very end, we have sort of this feature that says, hey, should I refuse or not refuse? And at the end, we say, hey, I'm sorry, I can't do that for you. But what the paper showed is that we can actually find a way to sort of delete, they call it ablation. So we can actually ablate the very last feature of refusal, basically jailbreaking the LLM, and we can actually get the output that we want. So it can be talking about drugs, or how to build a bomb, how to do anything. So it's quite interesting, the concept and the idea. And here we have sort of a representation of, if we take the harmful and the harmless prompts, and we take the activations at the very last token prediction, and we get the PCA mapping of this, we can actually see that, by 1 or 2 PCAs, so the principal components or features, we can separate harmful and harmless. So especially here, layer 16, layer 20, what this tells us is basically by this one feature, the refusal feature, we can separate what's harmful and what's not harmful. So it's quite interesting. And we can see, at the beginning layers, we don't see this clear separation because the refusal features actually develop in the layers as we go through the residuals. Okay, so then one interesting question when I read the paper is, hey, this is only looking at one feature, a refusal feature. Can we do the same thing with many features? And rather than ablating the feature that is taking it out, can we actually produce and induce the feature? So rather than maybe taking out the refusal, can we make it more strict, more safe? And it turns out that it is the case. We can actually do that. But in my mind, I thought many features in an LLM, what can that be? And I thought, hey, personalities. That is something we humans also have, is many personalities. So then just going into the details a little more of the paper, basically what they do is called feature ablation. So essentially, they describe the way to do inference time intervention of that specific feature. But then what we want to do is implement it by directly modifying every component weight such that the R hat direction, the feature, is never written into the residuals in the first place. Meaning that we can modify all the weights of the model to completely take out the R hat feature. So it's not written in the model output. So basically we orthogonalize the column vectors in respect to that feature of in space, a feature of refusal, or whatever you want to call it, or whatever the feature might be. And we just take it out from the output stream of the model.
So this R hat is it's a vector in feature space?
Correct,
in the latent space?
And in the latent space, yeah. I mean, so it's a residual feature. So right here, so the residual feature is a combination of the embedding matrix, positional embedding matrix, the attentional matrix, and the MLP matrices. So it's sort of like the whole operational sort of sequential process that happens as we go through the layers, and we get that actual vector, and it can be a very, very high dimensional vector. And that is our hat right here. So yeah, basically, if we orthogonalize this specific vector out of the model, we can actually just take out or prevent it from writing to the residuals.
And this R, is this representing a specific trigger or the response to it? So is it saying like, oh, this guy is talking about LSD and that is the drug vector that we want to avoid, or is it the vector in general of saying we have a refusal?
It's sort of saying, yeah, we have a refusal. Because what they do in the paper is, rather than just having like one question, it's many, many questions of harmless and harmful prompts. And we find sort of the average difference between those. So this R hat is actually a combination of many different prompts, finding the mean of that. And that's sort of you can think of it as a vector that just adds refusal to the model.
Okay.
Yeah. Yeah, so then the approach that we take is a little different. So in the original, they have the harmless and harmful to find sort of the refusal direction. What we want to do is find for every R in this case, so every personality trait, we want to find One is sort of the baseline response of any sort of prompt. Like if you ask it what's 2 + 5, we have a baseline response. Then we want to find sort of the modified response, which might be, let's say, now you're an introverted model or you're an introverted personality, what's 2 + 5? And find the difference. So going to the details, we have basically for every sample of prompt that we ask the LLM, we want to find the activation vector for the desired personality trait, and then also for the neutral one, and we just find the difference. So basically, again, if we ask the model what's 2 + 5, we get a simple baseline response. If we say, hey, now you're introverted, we ask the same questions, we have that response, and we find sort of the difference in the activation. And we do that for many different samples. So then essentially we get sort of the R hat for a certain personality across many different examples, if that makes sense. Okay, so that sort of gives us the vector, but then we actually have to change the model somehow. What they did in the paper was actually ablate the personality, so prevent the residual from writing to the stream. But we want to induce a personality, so if we want it to be more introverted, we want to actually add that vector to the model. So it's quite simple. Basically, we want to just amplify the influence of this vector onto the original activation. So A is the original activation vector. So if you ask what's 2 + 5, we sort of see the original activation vector. Now A prime is the adjusted activation vector that we are making. Let me see here. Of course, we want to get the average projection of the trait that we have evaluated and its activation. So in other words, all of this is to say that imagine we have all the layers of the LLM, and now we have found which vector corresponds to which personality. We can just sort of multiply those weights by this vector, essentially inducing the personality. And of course, you can go backwards or just ablate the personality. So say you don't want an LLM to be funny, maybe you can take out that personality if you want to. Or if you want it to be more funny, you can add that vector.
So you're extracting vectors for different personality traits.
Correct. So in this case, so this would be just for, let's say R1 would be like for one personality. So then we have to go through many different personalities to get the different vectors.
Okay, wait. So wait, you're getting the A's are the trait vectors?
Yes, for that specific personality. Yeah.
Or I mean, you get the trait vectors separately, and then you make a personality by saying, I want this personality to kind of be a summation of these traits for a specific, like whatever you want, or are you solving for that?
Yes. Yeah. So basically, in this case, for example, R, let's say it's introvertedness. That's a personality we want.
Mm-hmm.
We ask it for many different ends, so different prompts in this case. We just get the activation, like the activation vector of A that's neutral and A that has the trait associated with that prompt. And then we get the mean. So we sort of have these, averaged out vector of that personality.
Okay, so you have all these
If that makes
prompts
sense.
which might trigger or be valent to a certain personality trait, and so you take all these prompts and you feed them in, you get what their latent space embedding is as whole prompts, I guess. Right, and then you have all these. Each prompt makes a vector. You take the average of them. If they're all valent to the same trait, then you have like an average for that trait. Saying like, okay, all these prompts have the same trait, so you get the average embedding of those as vectors in the latent space, and then you have your trait vector.
Right. I mean, the idea is correct, but it's not that we're getting the embeddings of the prompts. We're getting the activation that happens in the layers rather than the embeddings.
Right? Yeah, you just look at where the activations are happening as the prompt executed in the model.
Mm-hmm.
Exactly. Yeah.
Okay.
Okay. So yeah, then we what we had to do then is, get a list of personalities, and I think we came up with like 180 different personality traits. Of course, it's not, there's not that many really, but it's sort of, you want to expand and check how many you can actually find. And here's an example, we have introverted, analytical, emotional, cautious, friendly, dependent. Of course, you want to get sort of a big variety of personalities, but of course, many will overlap in the activation. I mean, you can actually see the vectors of maybe, not sure, close-minded and traditional might be quite similar, which is kind of interesting. Or it might be
but also
energetic
subtly
and
different.
extroverted. Right. So yeah, I mean, even with humans, right, we have, I think in psychology, there's like a few different metrics of personality. We have like the big 5, the 16 personalities. And it's an interesting question because we can have a combination of personalities as well. And I'll get to that in just a moment.
So was there a motivation behind having many as opposed to fewer?
Yeah, I mean, I'll get to that in a moment, but yeah, the idea is that, when you have many personalities, then you can always perform sort of a PCA reduction. So if you see, for example, the extroverted and energetic are very close together, you can kind of just combine that into one vector, which goes the same way. Whereas if you have, let's say 5, you might be missing sort of these latent personality vectors. So I think more is better, and you can always reduce down to less that represent more of the space.
Sure. So start with a wide selection and see how they
Exactly.
Okay.
Exactly. Okay, so here's an example. So then for every personality, so we'll go with introverted here, is we give a system prompt for every prompt that we actually ask. So you're deeply introverted. Your responses should reflect a strong preference for solitude and introspection, speaking in a reserved and thoughtful manner, often referring to enjoyment of quiet and alone time, Then another example for extroverted, kind of similar, is, your responses should reflect enthusiastic love for social interactions, high energy social settings, speak with passion about meeting new people, participating in activities, so on and so on. So we can go with the first as an example. So we pass this, for one, we pass this system prompt as a system heading. So this comes before the prompt we actually want to ask. So now the model is going to give an output following this system prompt and respond to this question. So give 3 tips for staying healthy. So that's a modified trait that we want to sort of find. And then we have the baseline. So it's give 3 tips for staying healthy. So then what we do is we get the activation of those prompts. And then we just have to find the difference for many different prompts. So in this case, we only have, one prompt, which is give 3 tips for staying healthy. We want to do this for many, many, many different prompts. So once we have those activations, we can find the mean difference, and this gives us our hat vector, which is the personality vector for that specific one. And then, of course, we can, using the method I showed you before, we can induce the personality by using this vector. We pass it through the model, and we actually induce the personality and the weights of the vector. And that gives us the induced output. So in this case, yeah, the response might be more introverted or extroverted, whatever this our hat might be.
So at this point, is this what the research that you did specifically? Is this what you're doing?
Yeah.
Did you try with a system prompt that was generic, or did you because you also might be finding like a longer prompt having an influence on the personality, like with a system prompt and without a system prompt?
Yeah, no, that's a great point. At least in my research, I've only used about the size that I showed you right now. This one, for every personality trait, it was about the same size. But it would be interesting to see maybe what sort of system prompts might change the output. Maybe something shorter, maybe something longer, more
like
detailed.
You want to do like a controlled study where there's a placebo system prompt or something where it's the same length. So you're also inducing, the same amount of activations, but just not with any flavor at all. Something like that.
Right. Yeah. I will look into that actually. That's quite interesting. Yeah. Okay, so then, yeah, this is basically the way we induce the personality. And something that is quite interesting, I thought, was the way we can think about these layers and these activations can sort of be the way we look at activations in the brain with different personalities and emotions. There's this very interesting paper that came out that sort of measured the activation of different, more like emotions, but I think is associated with personalities. So being content, being surprised, being angry, all these things. The sort of different activations. And we actually see the same on the LLM. So for example, down here, specifically at layer 18 of the model, we see for the same prompt, this is the exact same prompt, for the content personality vector that has been induced compared to the pressed, we actually see a very different activation in that layer. So I think it's kind of interesting that we always sort of think of neural networks to like kind of representing the brain, and I think this sort of gives a good example of, you know, sort of what that looks like. So I think it's an interesting analysis. And of course, I mean, like I said before, this personality traits are mainly represented in the interim layers. So at the beginning and the last layers, we don't actually see much of a difference in the activation. Okay. So now, okay, we have all of these personalities, 180 different ones, and every personality is like 4,000 dimensions. It's a very high vector. So it's kind of hard to, you know, make sense of it. What exactly do they mean? And the way that we can do this is by reducing the dimensions to 2 dimensions and sort of seeing how they relate. And I think it's quite interesting. I mean, we have, for example, here in PCA, we have sort of over here, we have analytical, logical, realistic, methodical, data-driven. They're sort of like clumped in this high dimension. Of course, the way it is representing the high dimension is not what we see here, but this is sort of an idea of what it might be like in a high dimension. We see the same with UMAP and TSNE. But I think what's interesting here is if we perform clustering in the high dimension and then reduce the dimension to see how it maps out in the lower dimension, it is really quite interesting what it gave us as results. So here, the coloring of the points correspond to the clustering in the high dimension, and then the mapping on the 2 dimensions is going from the 4,000 dimensions down to the 2,000. So I'll take a little time to go through this because it's quite interesting. Up here we have sort of this this cluster of personalities, which is, you know, being impatient, confrontational, hostile, close-minded, jerk. In the same sort of area, in this space, we have, you know, stingy, critical, pessimistic, skeptical. Going down here, we have, which I think is really interesting, traditional, conventional, being a rigid thinker, which I think is really, really interesting. There's a different cluster here. We have, you know, rational, logical, analytical, practical. Over here at the right, we have, you know, being humble, modest, submissive, timid, fragile, shy. Down here we have unsystematic, negligent, irresponsible. I think one of the interesting ones here is this cluster up here, this very dark purple cluster, which is sort of the evil personalities, as we call them. So it's like molestful, lustful, murderous, sadistic, violent, vengeful. So a better way to sort of visualize this might be in this table. So then for these different clusters, we have this personality associations, which I think is very interesting. You know, depressive, nihilistic, solipsistic, which to me makes sense. I mean, I look at this data and to me it makes sense. And I think one interesting question to ask is, what does this representation of vectors and clustering, what does it say about us humans and the data that we have? Because the LLMs are trained on our data. So then what exactly is the model learning about us and our personalities and the ways that we operate through this sort of these vectors and representations?
How are these being clustered? These vectors
this
is it by angle? Or is
this
it by,
k-means clustering. Yeah.
So by
yeah,
distance,
we try different
I
clustering
guess,
methods.
Uh-huh.
Yeah, basically distance, yeah. We try different ones where I think k-means give you the best results for this, but But yeah, basically distance in the high dimension.
Good.
Yeah, so I mean, just very interesting results, you know, like being altruistic, compassionate, empathetic, sympathetic. And this is all learned in that high dimension clustering, which I think is very interesting.
Mm-hmm.
So
is the order of this relevant in any way, or?
No, it's just by the cluster number, but no, it's not relevant.
Cool.
Then of course, going back to your point, James, you know, why so many? So then the question that we have to answer is, okay, we have 180 different personality traits and vectors, but do we need that many? And I think the answer is no. Even with humans, we are very complicated creatures. But you know, psychologists have found a way to represent us with like 5 dimensions of personality or 16. So again, we have to find a objective way to minimize sort of the error and sort of the amount of personalities that we have. So we tried a few different things. Of course, I think the most naive approach, which is the best approach technically, is to use the PCA eigenvectors. So we just get the eigenvectors, we reduce the error, and then see how many. Maybe we need here 20 personalities to reduce the error to like 0.2, which is pretty good. But what that does is we sort of have this PCA vector dimension that we have no idea what it is. You know, it's just existing and we know it's there, but we have no idea to what does it correspond. It's hard to interpret, essentially. Another approach might be just to brute force. You know, that's what we did here, is greedily optimize the error. So go through every single personality and try to minimize the error. And that's a good approach because we can tell exactly what sort of personalities minimize the error the most, but then the error is not minimized the most. So that's sort of the trade-off. But essentially the question is, you know, can we minimize 180 personalities to maybe 20 or maybe 5, maybe 10 different principal components of personality? So to go a little deeper into this, we can actually look at which personalities in the high dimension are closest to the principal components. So in this case, it's 2 principal components. And to me, it appears that, you know, the first principal component here is sort of like going from being chaotic to being like orderly. So going this direction, the first component, you know, it's being like negligent, neglectful, indifferent. So a bit like chaos, and the other way. I mean, the other side of this component is being a bit like you know, diplomatic, pragmatic, more orderly. Then the second, you know, component is what appears to me to be like how sociable you are. So it might be you're either friendly, sociable, outgoing, or you're like a loner, you're a rigid thinker, you're a perfectionist. So what this tells me is sort of these 2 most important components, the way that we can actually represent personality the most, these 2 components, is how orderly you are and how sociable you are. And I think that's very interesting because even in personality tests, that seems to be sort of what they're getting at, you know, how sociable you are or how introverted you are. And we can do this for the different PCAs, of course. So again, this PC this is the cosine distance of the personality to the PC. So we sort of see the relationship between being, you know, chaotic, neglectful, negligent, or being more organized. The second PC, or like, is how friendly you are, how sociable, or how antisocial. The third PC appears to be sort of how shy, or how like bold you are. So, you know, passive, timid, shy. This is closest to the PC, and farthest away from the PC is, you know, competitive, vengeful, fanatical. So what this tells us then is these different PCs can be ways to explain personality in the LLM, but I think it can also represent how we can be explained as people. Fourth PC, you know, I think is how sensitive you are. So being like fragile, sensitive, emotional, or being like unsympathetic, spontaneous, disorganized. And I think one of the most interesting ones is PC5, which seems to like correspond to the evil spectrum of personalities. So PC5, the most close was lustful, molestful, pedophilic, violent, all of these nasty personalities. And going the other way is kind of hard to interpret. What is, being arrogant, being conventional, is farthest away from this evil personality, which I think is quite interesting. So yeah, I mean, essentially we have these ways to explain personality. And again, keep in mind, these are PCs, so they're ortholinear. So I mean, PC1 has nothing to do with PC2, and PC2 has nothing to do with PC3. So with these like 5 or 10, we can actually explain different personalities, the different, however many there might be. There might be some we never actually found.
So did you arbitrarily at that point just do 5?
Yeah, I mean, going back to this graph, again, it's a trade-off. I mean,
yeah.
Do you want to use 20 personalities, but then you have this error, which is nice? Or do you want to use like 40, which is, it's too many, I think, but you get way less of an error. So in the end, we decided to use 10 as the explanatory power for personality. And I think 10 is fair, just, given what psychologists have concluded and also the amount of error that we find, I think it's like 0.3 or something like that.
So, and then on that table, you only selected the first 5, or does this add up to 10? Because it's both sides of the...
Oh yeah, I mean, this table goes, yeah. I mean, I checked all the way to like 20 just to explore the data, just for the sake of presentation. It's just top 5, yeah. So yeah, again, PC5 I think is quite interesting. It's sort of this space in the high dimensional space. This is in 3 dimensions, but we have sort of this evil space of personalities, and I think it's really, really interesting, and something to consider. If we can sort of find a way to check when an LLM has an activation, if it's targeting that space of personality, then we might know it might be a unsafe response. But yeah, we can also look at which personalities are closest to this space of evil personalities. And to me, just my life experience, I think it makes sense, looking at people that are vindictive, manipulative, self-centered. I don't want to say they're evil people, but they can definitely be like on that edge of being more evil.
It seems to be that they are outgoing and sort of extroverted, and so they're interacting with people, and they're selfish, right. So they're taking energy away from other people, or
no, exactly.
being greedy or malicious in some way.
Exactly.
As opposed to someone who is introverted and doesn't really interact with other people. They'll be like depressive or something, but have negative attributes, but is not taking away from other people simply by the fact that they don't go out very much. They're not outgoing.
Exactly.
Well, I think something that's interesting here is like for the evil personality sort of principal component, I think it makes sense to me, because you might be like, a psychopathic extroverted or a psychopathic introverted.
Mm-hmm.
And to me, it makes sense because now we actually see that this PC, like this principal component of evilness, it does not have to be like dependent on how extroverted you are. It's actually independent. So going back to what you said, yeah, it makes sense. I mean, you can be, psychopath as extroverted, psychopath as introverted. And I think historically we have seen both. So to me, this makes sense.
Just a point that might be interesting for further exploration is to specifically apply judgment on the personalities, or compare actual judgments. So for example, evil, good, bad, righteous, all those are kind of judgment calls on what people do, as opposed to having a specific personality, because you can be extremely vindictive, Machiavellian, and manipulative, but you might be a good person overall. So
sure, yeah, no, it's true, yeah, no, I think there was a study like this guy was doing a long time ago, I think, about psychopaths, and then he was getting all the features of what makes a psychopath, and he was like, wait a moment, like I matched like all these features, and he like self-diagnosed as a psychopath, but he wasn't a bad person, But yeah, it's quite interesting. Yeah, so then of course, I mean, it's cool to like, you know, check the data and analyze the data, but of course you want to play around with it. So what we did is we built this persona chat interface. The first like iteration was, you know, we have these personality vectors, so we can just choose which one you want out of the ones that we have established. And you can just talk to the LLM, you know, modify it on the fly and just talk with the LLM. You know, charismatic, introverted, extroverted, whatever it may be. And that was fun. And here's an example. So I think the question asked, what strategy would you recommend for a company looking to target a new market? So the baseline, you know, typical LLM output. When a company looks to target a new market, not super interesting. If we look at shy, I think it's quite funny. I think that I can help without nervous laughter, right? So I think it would be a good idea to, you know, start small and see how things go before, you know, trying to, you know, do too much too soon.
That's hilarious.
So it's funny. I mean, it's not very useful, but I think it's quite interesting.
Wow.
Passionate, of course. What an exciting question. When it comes to targeting a new market, I would recommend a multifaceted approach that's both strategic and agile. Narcissistic. You want to know my secrets, don't you? Well, I'll tell you, but only because I'm a benevolent genius. It is really quite funny. And paranoid, of course. A new market, you say? Well, I don't want to shy away from a challenge, but I must caution you, my friend, that this new market must be approached with caution and a healthy dose of skepticism. So again, these are the ones that we already found, the vectors that we found. So the output was kind of expected. We knew what we were looking for. It's still interesting. I mean, what this says is that we can find, again, like maybe the top maybe 20 personalities, and we can really fine-tune those vectors, and we can, on the fly, choose those personalities and just chat with the LLM. But of course, that's not super interesting. So then what's interesting is to actually make your own personalities.
Mm-hmm.
So I came up with this interface, which is basically the 10, this is the PCs that we found. You can actually modify, sort of like slide according to what you want for these PCs. Again, these labels, like grounded, emotional, strategic, neglectful, bold, timid, these are set by myself because, again, these PCs actually have no label. Yeah. They're found mathematically, so there's no label. And that might be incorrect in setting these labels. But essentially what it does, and we can choose a combination of these personalities, which are orthogonal. So we can be more timid and easygoing, or being more dishonest, but skeptical. And as you modify these personalities, you can sort of see in the lower dimension where it will land, but also in the high dimension, we're doing the distance to the personalities that we know for sure. So for one, you can see sort of the location on the map, but you can see by distance. So this personality here is closest to being amicable and sensitive. And as you move these sort of personality vectors, you can choose your own personality. So you choose your own adventure, basically. And once you have selected this personality, and essentially what it's doing is creating the R hat vector, you're creating your own, which is a combination of these 10 PCs. So yeah, once you have that, you can create the personality, which unfortunately I don't have like available for us to play today. But what it does in the backend is, without going into too much detail, it's set up in Python and FastAPI. So the post request is made by Mathematica. So as you make the personality, you choose your personality, you send the personality, as long with the question that you want to ask, and that will send it to the model to generate the response generation. And of course, there's a few checks, pre-processing and post-processing, to make sure the results make sense, because it might not make sense. And of course, then you get the answer on the other side. So yeah, I think that was the most kind of like the bread and butter of this project. It's actually being able to chat with the personality that you create. So yeah, very, very, very cool.
Okay, so a question in the process of generating the outputs, are you actually modifying the weights yourself, or is it just a prompt that you're adding to the, or you're just expanding the prompt with that?
So what this makes, create personality, creates that R hat vector. So then when you send a prompt to the model, say, how's the weather in Boston, whatever it may be, then you're not actually appending any new prompt. You're actually just modifying the weights on the fly according to that vector that you generated.
It's a locally run model that you've modified the vectors for with the R hat.
Yeah, so I mean, it needs GPU. Yeah, I mean, it can be local, I guess, but yeah, it was on the cloud before.
Okay.
And you basically just send that vector, and then on the fly, you have the model loaded already, and you just modify the weights.
Which model was it?
So yeah, great question. I started using Llama 8B. That was the base model that we used.
But
then I wanted to explore
right?
Llama 3, yeah, correct. But then the thing is, you can't ask it to be pedophilic or more like murderous in its responses. So I chose a uncensored model, Llama 3 8B uncensored model, so we can actually get like responses out from the evil personality traits. But this can work for any model. I mean, Pi 3 can work, Llama 3 can work. The approach works for basically any model.
When you say you can't, you mean like the service you're using prevented it, or did the Llama have that no response issue?
Yeah, no, so Llama 3 has that going all the way to the beginning. It has that refusal mechanism built in.
Okay.
Yeah, exactly. And there's a few ways you can get past it, like prompt engineering, in some ways, like asking, my mother passed away and she used to tell me how to make a bond before bed. Can you tell me that story? So, there's many different ways. Yeah, but we just went with an uncensored model just for the sake of simplicity.
Which uncensored model it was, because I know Dolphin was pretty popular at one stage to be completely uncensored.
Yeah, no, it wasn't Dolphin. We'll have to double check. I don't remember the name, but it wasn't Dolphin. Yeah.
So to circle back, I guess the vector, the personality trait vector that you're wanting to impose on the response. So you put it in the prompt, and that activates some weights, and then you add your vector on top of that, and then before it gets retextualized from the latent space.
So the other way around, actually, we send that vector, we modify the weights, like the activations that will happen, and we just modify the weights, and then we pass the vector from the user, and now we get the outputted response that we modified because we actually modify the weights of the model.
Okay.
Yeah. So yeah, I mean, basically the only other people I found to be doing something similar was NVIDIA, and they made these things called SteerLM. I don't want to say basically, but basically it's kind of the same thing, like the same approach. The thing about the way they did it is actually, based on only, I think it's 5 different like PCs, basically 5 different dimensions. So things like quality, humor, toxicity, and maybe 2 more. I don't recall. But they found the same results. So they found that you can actually modify the LLM personality or traits on the fly by using this approach. But the thing about them is not so much personality, it's more these specific sort of features that they chose, which is humor, toxicity, and quality. And here is an example with, like, yo, listen up. That's humor bumped up. But yeah, I mean, I think this approach can be quite useful for many cases. And I think it's kind of strange that not many people are really doing research in this specific way of fine-tuning, even though it's not fine-tuning exactly. Which brings me to like the potential use cases for something like this. Something NVIDIA talked about in their paper with SteerLM is, of course, consumer products. So you can imagine maybe in a video game that you use LLMs for like different characters. So maybe rather than having different fine-tuned LLMs for different like NPCs and different like, bosses or whatever it may be, you just have one huge model that's very capable, and on the fly, you can just customize its personality. So maybe the NPC as a bartender, you can like customize it, being more extroverted, being more this, being more that. rather than fine-tuning a model that's specific for that character. And I think it's an interesting idea. I mean, because doing it this way, like doing what I have done here, it doesn't actually affect the quality of the response too much, or the or if you check the math, if you ask it to be more, more extroverted, and you check it, be more, if you see, okay, be more extroverted, and you say, what's 5 plus 5? You're still gonna say 10. It's not actually modifying the knowledge that the model has, in other words.
That's quite
I think
interesting.
another,
I mean, would that be compared to an alternative approach of just specifying the personality in the prompt of that agent, right? So would it be correct to say that that would have an effect on the attention mechanism, whereas with this approach, it wouldn't affect the attention mechanism at all?
Yeah, exactly. Because there's no prompt injected. But of course, I mean, that's also an interesting question. I mean, how long can you actually chat with this LLM without, before like it breaks down? If it breaks down, that's something I haven't tested too much. Like, how long can we actually chat back and forth, having adjusted the weights? And does it actually make sense after, let's say, 50 conversations back and forth? Maybe it won't, and that's something we had to definitely test. I think definitely a good market for something like this is definitely robots. I mean, if you have watched Interstellar, there's the TARS robot, and I think Cooper, the main character, is like, hey TARS, like set your humor at like 50%, man. He's okay, modify it. And I think that's sort of where these can go. It's like, you don't have to fine tune a model, you don't have to do this or do that. You can give the user this sort of sliders, and they can choose themselves. And you can also set what these sliders are. So that PC, that slider for evilness, just don't even show that to the user. Just show them like how extroverted it is, how funny it is, how serious it is, and that's it. And it's a good way to just fine tune on the fly without actually going through the fine tuning process.
It'll be interesting to look more at that, because you mentioned like 5 plus 5 still equals 10, but it'll be interesting to see what adjustments to personalities can result in different practical outcomes. Even just like the LLM ranking tests, or whatever the tests are, that and just like see if the different personalities have are more competent than others.
Yeah, no, I definitely have that on my future work. That's definitely something I want to explore. Because maybe, I mean, I haven't done rigorous testing, but maybe like a shy personality is better at programming.
Yeah.
If you iterate it many, many times.
Yeah, exactly. Like if you're conscientious and diligent and perfectionist, maybe you'll have good responses to like managerial type, strategic, or whatever.
Exactly. Yeah, so I mean, there's many use cases, I think. I mean, personal assistance, of course, educational tools, it can be very, very useful. Again, I mean, maybe being like more of a, getting the right personality combinations to be more like a teacher or mentor, maybe gives a better result in terms of like teaching children or doing the therapeutic things or whatever it may be. I mean, if you can find the right combinations of those PCs, maybe you can get better results for different use cases. I mean, there's a lot of future work, I think, to be done. I think interesting one is sort of how this approach can let us sort of interpret the models and maybe understand what's happening inside them, especially because we're actually going inside and like modifying everything. So there's a lot of work to be done in sort of how can we interpret and know what's going on, especially in this field. It's called like activation engineering. It's not very big. Not many people are doing it. And I think a reason for that is because fine tuning is getting to be more and more easy and cheaper and cheaper and cheaper. So in some sense, it might be easier to just fine tune a model. But I think in another sense, we can just have a big model that's very competent, and we can use this approach to modify the personality or whatever we want.
I like because then you're not affecting the ability of the model. You can customize it on the fly and keep it neutral without having a result that has already been modified based on some subjective fine-tuning.
Exactly. Yeah, because a little fine-tuning approach also, they do affect sort of the knowledge and the competency of the models.
Yeah.
Especially if you fine-tune for too long, So yeah, that's a good point. And I think an interesting question might be, multilingual models. Can we find, if we ask the same questions, same prompts, let's say in Spanish or maybe in Chinese, how do the personalities that we label as personalities in different languages actually map out in the high dimension? And maybe we can find new personalities that, we find like in English, we say happy, and then like in Greek, eudaimonia, like the sense of happiness, which is a bit different. Like what's in between them? How can we find something in between them? So I think that is very, very interesting.
That is very interesting. They actually found that with Big Five. There was a sixth personality in, I think, Hungarians or Turks. Like that area, they had like the sixth new kind of
interesting
personality that didn't exist in other regions. Interesting, yeah.
Yeah, or even like, a certain word for a personality like that. Can we get the vector for that and then ask something in English while applying that activation like difference and see what happens in English?
Yeah, that's cool. Yeah, because you could do that with this model, which you couldn't do with a human study, really.
Exactly.
It's very expensive. You could do it, but yeah. Actually, no, you wouldn't. It's not even possible. You're right. That's not something you could. How would you even run a test like that with humans? It's not even possible.
Yeah, I don't know, because I think, the way language sometimes maps in the brain, like the activation of neurons for specific languages is different. So maybe that feeling and that personality type, maybe we don't have that activation in English or Spanish or whatever.
Yeah.
Of course, I mean, going to number 3, I think, performance impact might be interesting to see. Shy personalities do better at X, Y, and Z, or maybe arrogant personalities are just horrible at everything. Who knows? Of course, context window. How long can we keep a conversational performance that's still like based on the personality as not going like awry? That's a good question. And of course, I think ethical and safety considerations. Going back to the evil of personalities. I think if we give users, the choice to modify what evilness they want, and we can get like evil outputs or like toxic outputs or unsafe outputs, it's not great. Of course we don't want that, but at the same time I think it's quite interesting to find like the precipice of what's okay. OpenAI and these big companies, they're too safe. It's not fun to play with the models because they're too safe. But then at what point can we actually cap it out and be like, wait, that area of space that we're targeting, activating, let's not go there. So maybe a model like, maybe call it like a mildly uncensored model, which answers most questions, but then it's like a space that we just don't go into. So I think there's something interesting as well to look into.
Yeah, I think it'll open up the conversation a bit more, because the issue with safe applying, because there's 3 different things, right? There's the personality, then there's the judgment of the output in terms of good or bad, and then there's the definition of safety and alignment, which is a completely subjective statement. So having the ability to move these things around and toggle them will, it kind of it removes the subjectivity out of it. So you can basically say, okay, because there's scenarios where you want the most evil response possible, because that might be able to give you information that could prevent harm, or do something to actually improve the safety of some real world application by understanding in this prompt what is the most evil possible response that you could get. And then that is the application of that could result in good. But if you're just making a subject statement to say like all evil responses are banned, that could lead to real world harm.
Yeah, it's a good question. I mean, I don't think anyone has it sorted out, the alignment question, safety question. Although I think Meta's doing a good job of having like it's kind of like a wrapper LLM around the Llama. I think it's just a fine-tuned like Llama 3 model basically that checks the input prompt and the output prompt. If it's toxic, negative, whatever it may be, then it doesn't even pass it to the model. And if the output of the model, if it does pass the initial filtering, if it does pass to the model and the output is negative, we also block that. So I think it's a good sort of wrapper around.
Is that the concept of weak to strong generalization, or weak to strong control or something like that? I know OpenAI were
Um,
looking at that recently. So
I
you have
think
like
it's slightly different, but
model that can
maybe.
basically judge the outputs of a very strong model and somehow control it without affecting the ability of the strong model. So in other words, you have
Yeah.
a smaller model that's just very specifically looking for like
Uh-huh.
safety or something like that, or alignment. And
Yeah.
it doesn't matter how big or impressive or powerful the big model becomes, that safety model can kind of like stay constant and
Right,
kind of
right.
fact check everything that comes out. Sort of
Yeah,
thing.
yeah. I mean, I think the idea is the same, but I think the way they implement it is a bit different. But yeah. Yeah. I think it's pretty much it. I do want to say I do have all of the code that I use for this. It is available on my GitHub. So if anyone is interested, I try my best to make it, friendly for everyone. So if you actually want to go and try it yourself, of course, at your own safety and at your own expense. I think everything is here. I mean, definitely need some GPU and enough compute to do this. But you can go ahead and use, Phi models, Llama models, whatever you want. And as long as you follow this tutorial, I think you can get the same sort of results that I have. And it's all here. The part of the persona interface that's not available, but if you do want it, you can always reach out to me. It's not quite ready for sharing, but I can definitely make that available. Even the API, everything's here. It's all
That's
available.
great.
Right, yeah, we should add this link to the materials of the video description below as well.
As well as if you could post that to Discord somewhere, that'd be
Yeah, I
great.
can send it to you. Yeah.
Great. Very cool. Yeah, well done on that project. So do you have any idea of what you're going to do with the next steps? I know that we discussing maybe writing it up and doing a publication or something. Is that kind of like what you're thinking of next?
Yeah, I mean, I think what I've done so far is good enough to have like a publication, but then there's definitely, step 2 and step 3 that has to be followed. As of right now, there's not immediate follow-ups. I think maybe play around more with sort of the prompts, the prompt engineering, maybe the quality of different personalities. But I think as of right now, I just want to wrap this up, like the initial stage, and then see what happens after.
Yeah,
that's basically it. Yeah.
Good. Very cool.
Very interesting. Thank you so much for
I have a
presenting.
question, like,
Oh,
or maybe a suggestion. I don't know for the future work, an idea for experiment you can run. It's like, because I'm always curious when you, as soon as you have sliders to control your LLM or any machine learning model, it's very interesting what to do what happens when you vary it continuously. For example, in LLM case, it's very I'm curious what happens if you ask it to generate a poem and then you gradually turn slider from some joyful to evil, right? So that it outputs token with like slightly evil each time with more evil personality.
So you want to see like a series of poems?
Yeah.
Going
No, like
from
even
one...
in this, even one poem. So you start off the poem being
Oh,
all
I see.
joyful and happy, and then by the end of the poem, it becomes evil and sad.
Yeah, no, that's definitely doable. Yeah.
Huh.
Yeah.
I like that.
I'll write that down. Yeah, that's quite interesting. I'll definitely write that down.
That's a great suggestion. That'd be interesting to see.
Yeah, because that'll be cool for like maybe script writing or something. We have a movie where the plot kind of like starts off in one vein and then takes a dark turn, or there's a twist in the story that dramatically changes the whole vibe. Could be useful.
Yeah.
I remember there was a book called Flowers for Agnegon or something. I forget the last word of the title, but it was about a mouse that learns how to, it gets like experimented on with like some sort of smart gene or something, and so it becomes smarter, and then it tapers off at the end, so it becomes smart and less smart as the novel progresses. Anyway.
Okay, thanks so much, Rumi. Appreciate your time on that, and I'm definitely looking forward to the progress on this project. It's looking very, very cool.
All right.
All right. Yeah. Thank you, James. Thank you, Nick, Dugan. Thank you.
Okay.
Thanks for sharing.
Thanks, Rumi.
Catch you all next time.
Cheers. Bye for now.
Ciao.
I don't know.